Hi everyone. In this case, I say the steps of the do a deflection in beams by energy method in virtual walk. First, I have the problem determining the maximum deflection of the steel beam shown in the figure, in this one, and consider that E equal 200 G Pascal and a 70 por c square 6 meters square 4 by means of the conjugate beam method. And then the explication I read see in this beam I have a force of 12 kN and my distance in the input A on the point A it's to the force it's 9 and the distance of the input B or the point B to the distance is 3 meters. And then with my beam I have a symmetry force to the momentum A and equals 0, and then it's negative 12 force por 9 multiplied of 9 more Bj. That is the force I in this case charge, and then do a summatory of force in j's. If j it equals 0 and aj negative 12 more 9 aj is resumed or in a executive it's 12 less 9 and equals ag it's 3 the force of positive to the up and my input, and then in bj it's equals 12 multiplied 9 divided into 12 equals bj equals 9, and it's the force in the input B. And then with my force have do my two diagrams, coordinate and momentum. In the coordinate have 0.8 and up to 3. It's my force charge in the interior step and up 3. And then with is a force consecutive to the 9 meters and down 12, you in my diagram of coordinate use 3 up and then consecutive and the 3 last 12, and then my result is less 9 and the point of the 9 meters it's 9, and then it's consecutive and up 9. It's my coordinate charge in the step. It's the similar. And then in my momentum, my diagram of my momentum do with a area of my coordinate. For example, 3 multiplied to 9 it's 27, and 9 multiplied per 3 it's less 9 multiplied for 3 have 27 but down, and in this case it's 0 and my momentum it's a triangle form, and then have a 27 EA. Then I have or I divide my triangle in a subsection. My large section and my less section and my small section, and do a divided my 27 divided to middle of my triangle because it's in the middle. My forms punctual, it's in the middle of my triangle. And divided 27 divided to 2, and my result is 120.65, sorry, 5. And in the middle, in the left, have 27 less 12 with my area, have a 40.5, and it's the force see in this diagram. And in the triangle have a condition. It's of 3/4 of the rectangle, or my angle of 9 grades, and or to the my angle in the section, in the final section, to one quarter, and it's the location like that. And then put my force, this force or that force, search with a summatory force. First, I ensembled, or I propose my force in the input 8, and then it's 121.5 divided all the force divided to EA, because is the component used in the momentum in the final step, and it's important. And then multiply to 6 more 40.5 divided to EA, and it's the elastic model, and multiply to 10. Why? Because 6 more 4, it's 10. It's the distance have in this force, and 6, it's obviously in the point A have a 6 force to the 121.5 to look alike in my bin. And last BJ multiply to 12, it's the whole bin use, and it's in this point. And then resumit or result my equation, my equal, and BJ it result to 121.5 multiplied for 6 more 40.5 multiplied for 10. This one divided to 12, and that's at equals to 94.5 divided to EA, elastic model. And then my force in AG, but I search this one, and I search this another, and then my summatory of force of FG, it's equals 0, and less my equation. Less AG more 121.5 more 40.5 more 94.5, it's the new force, and then AG equals 162 less 94.5, and it's equals to 67.5 divided to elastic model. And it's the result, and it's the force C in this diagram. And then and the final, use my diagram momentum, but have a section. I don't use all the bin, I don't use all the momentum, use a section. for that use x to my distance, but I don't know what is the distance. I don't know what is the value of my distance. I have a distance, but I don't know why. And in this case, use w divided to x. What is that? The momentum, and this one c, the momentum, 27 divided to elastic module, that divided to 9. 9, it's the area, or it's the distance have to the point A to the point 12. Okay, and then that is equals to the force half, or to the curtain half in this section of my beam. It's 3 divided to elastic module, 3 multiplicate x divided to elastic module, and then occupy this value to calculate my force or my x. Calculate my force in Fj, then calculate my x. It's the variable, or it's the constant. I don't know where is the value. And then use a summatory of Fg. It's equals 0, and then it's less 67.5 more this 1 divided 12, because it's in the middle. It's an area of triangle. This no change, this step don't change. It's the similar use in this case. Divide in middle, and then I search my force. And in this case I don't have more, but I put quarter multiplicate to 3 divided to elastic module, multiplicate x, it's my distance, but is the result have in w divided x, and that multiplicate to x. Why? Because my force localized in the middle, yeah, and then my distance on my alter, my height, it's 3 multiplicate to x divided to elastic module, and that, because it's a triangle, have to multiplicate to my distance, in this case is x, and that is equals 0. Despejate my equals, and it's 3x elevate square divided 2 in the middle, and then it equals 67.5 divided to elastic model, and then x, to despejate x, I have a root in x. In this case I don't put, because it's obviously I have a root in x, that's equal root to 67.5 divided to 1.5, because it's the 3 divided to 2, it's the result, and x is equal 67.08082. This or that is x. It's my distance have in this section of my triangle. Then I put the example in the first, but the final step is summatory of force. I have a force in my section A, or in my point A. J is 67.5, and use in my summatory, and then have a distance in x, what I search is 67.082. Multiplicate. Why? Because it's a momentum. It's the point do my momentum, and my point do that. I have a point in this section. To negative my force applied then, and I do that. That's it. That. And it's positive. Then multiplicate a middle 1 divided 2, multiplicate 3, it's the distance in my triangle, multiplicate to 60.7081, that divided to elastic model, that multiplicate of 60.7081, because is the distance have to my bin in the fourth string. It's the distance I search that, but I using meters, and then that multiplicate to 1 divided 3, that multiplicate it's the explication I do in the another step. In this step, the force localization in the 1, 2, 3 parts of the angle rect, and it's used in this section. Multiplicate to the x more momentum, that equals 0, and then momentum it's equals less 0.8692 divided to elastic models. In this case, change or replace or the selects a value. The value in this section is, remember, in A is 2 G pascals, 2200 G pascal, and in the I it's 60 multiplied 10 elevate to 6 millimeters, and then change my my value of momentum divided to E, that's 200 multiplied 10 elevate 9 multiplied to 60 multiplied 10 elevate 6, and then divided to 1004, because 1004, because it's a change of values and that have in meters, and now it's a correct use values of, for example, PS, FT, or for example inch, or for example pulgadas. It's an example. And my value of my momentum it's less 0.075 meters. It's 0.2550 centimeters, and that's all. Thanks for watching.